dy by dx of a function which is in xy form, like x plus y square, and you have initial condition that y at 0 will become 0. This is the initial condition. So the formula is very clear to you. Let me write it again. Yn is equals to y naught plus integral x naught to x function of x comma y n minus 1, the previous value. So as y naught value here is simply 0, the initial value, because y naught is 0, x naught is also 0. So we will write 0 plus 0 to x f of x comma y n minus 1 dx, and in this case, as it is 0, we can simply say it is equals to integral 0 to x f of x comma y n minus 1 dx. Hope this is clear to you. If not, put it in the comment, and don't forget to like and subscribe. Bell icon also. Thank you. Let's proceed. So let's go for the first approximation. For the first approximation, n value is 1, so y1 is equals to y naught is 0, so I'm not writing it, just 0 to x, limits, and function. Function is x plus y naught square. So you know y naught value is 0, so we can simply write it 0. We get only x dx, and the differentiation of x is x square by 2 with the limit 0 to x. So simply y1 is going to be x square by 2. That is our first approximation for the function. Let's go for the second approximation. For the second approximation, I am writing y2 is equals to y naught is 0, so I am not writing it again. Then x plus y1 square dx. You know y1 is this, so we will going to substitute it. y2 is equals to 0 to x plus, now when you substitute the value, substitute it inside the bracket so that you don't forget to square it. When you do that, you are going to get like this. Now square it first before integration. You are going to get y2 is 0 to x plus x to the power 4 by 4 dx. Now only integration works needs to be done. You know integration of x is x square by 2, and integration of x to the power 4 is x to the power by 5 by 5, but 5 4s are 20 we need to write because 4 already was there. Limit was from 0 to x, so surely you can mention it as y2. The second approximation is coming as x square by 2 plus x to the power 5 by 20. That's our second approximation. For the third approximation, you need to put, let me write it, approximation n equals to 3 in the formula, and y3 is equals to y naught is just 0, so I'm not writing it, 0 to x naught is 0, x plus y2 square. That's what we need to substitute. When you substitute it, what we are going to get, let me write it here, 0 to x plus, when you substitute inside the bracket so that you will not miss the squaring part. Okay, so when you do that, you need to first square it. You are going to get y3 0 to x plus, this part is x to the power 4 by 4 plus x to the power 5 to the 10 by 20 square is 400, and let me write it 20 properly, plus 2 times of these two get cancelled, and we can write x to the power 7 by 20, and everything needs to be integrated with respect to x. So y3 is equals to x square by 2 plus x to the power 5 by 5 4 is a 20 plus x to the power 11 upon 11 4 is a 44 times this, and plus x to the power 8 upon 8 to the 16 160. So that's our third approximation, and you can write it as y for your third approximation solution of y. Hope this is clear to you, and because this example is different from the previous one where you don't have the squaring part of y, here you need to understand that if you have the squaring part, you need to first square it and then substitute. Okay, so like that way I will keep introducing examples of different higher levels where you need to learn different things so that you don't make mistakes in your exam and you understand this topic well. See you in my next video with more examples on this topic in this segment. Till then, bye bye.